Hi students, now we'll discuss about the parallel combination of resistances. This is another types of combination of resistances. So parallel combination of resistances means here this is one resistor, this is another resistor, and this is another resistor. Three resistors. Suppose the resistance is R1, this R2 and this R3. So here the three resistors, the starting point is this one, for this starting point is this one, for the R3 the starting point is this one. Now if you connect all the starting point together, here we connect all the starting point of three resistance together, and similarly if we connect this is the end point and end point of three resistors. So the end point of R1, end point of R2 and end point of R3 also connected to the same point. So that means here the three resistors may be more than three. So if all the resistors starting points are connected together and ending points are connected together, then these types of combination is known as the parallel combination. Now for this parallel combination, we'll calculate the equivalent resistance. That means R1, R2, R3 when connected in parallel. So what will be the resultant of these three in parallel circuit? So now at first we draw this circuit. Here one source voltage, that is one battery is connected of source voltage V. So I current starts to flow. So when the I current reach to this point, then there are three paths through which the current can pass. So this I current when reach to this point, then this I current split into three parts. One part will flow through this, one part will flow through this, and another part will flow through this. Suppose through this branch I1, through this I2 and through this I3 is flowing. So when I current reaches to this point, then I splits into three parts, I1, I2, I3. Through R1, I1 current is passing, through R2, I2 current is passing, and through R3, I3 current is passing. Now if you apply here Ohm's law, but one thing, here all the starting points and the ending points of three resistors are same. This is the starting point of R1, starting point of R2, starting point of R3. This is the ending point of R1, ending point of R2, ending point of R3. So as the starting point and ending point of all these three resistors are same, that means same potential difference is given to all these three resistors. That means here potential difference across R1 is V1, because V1, the two end of V1 is connected here, sorry V, because here the two end of this battery is also connected to this point. So the potential difference across the two end of the battery and the potential difference across the two end of R1 will be same, two end of R2 will be same, two end of R3 also be same. So here the potential difference across R2 is also V, and potential difference across R3 is also V. So for the parallel combination, one thing we can say, for the parallel combination, the different current will flow through different resistance. Here R1, R2, R3, through R1, R2, R3 different current is flowing, but the potential difference across the three end of the across the two end of the three resistance are same. So this is the main things for the parallel combination. Keep in your mind the current flow will be different from through the different resistors, but the potential difference across the two end of the different resistors will be same because their ending point and starting points are common. Now if you apply the Ohm's law, now, if we apply Ohm's law, so we can write at first V is equal to I1R1 for this first. Here across the two end of the R1, V is the potential difference, current is I1, resistance is R1, so V is equal to I1R1. Similarly, from here you can write I1 is equal to V by R1, and again we can write V is equal to I2 R2, because for this R2 the current flow is I2 and the potential difference across the two end is V, resistance R2, so we can write V is equal to I2 R2. So from here we can write I2 is equal to V by R2, and again V is equal to, we can write V is equal to I3 R3, that means I3 is equal to V by R3. So for the three resistor we can write this one. Now if I draw another circuit, another case, that means here one single resistance R is used instead of these three, here we use one single resistance and other things are same same battery of source voltage V is given, and this R is equivalent to R1, R2, R3 in this combination of R1, R2, R3, and this R is same. That means the working of R in this circuit and the working of R1, R2, R3 in this combination in the circuit is same. So in the second circuit, or you can write from in this second circuit, we can write by using Ohm's law what V is equal to IR, I current is flowing. So from here we can write I is equal to V by R, I is equal to V by R we can write. Now here we get I1, I2, I3, but just think one things, that means why we get I1, I2, I3, that is due to the I. Here I reach to this point, then from the I, this 3, I1, I2, 3 we get. So we can write I is equal to I1 plus I2 plus I3. So we now will write that I is equal to I1 plus I2 plus I3. Now we put the value of I1, I2, I3 and I also. What is the value of I? Value of I is V by R, value of I1 is V by R1, V by R2, I2 and V by R3, that is I3. We put all this value in this equation. So here we write it first, I is equal to V by R, I1 means V by R1, that is V by R2, I3 means V by R3. So from here V by R, if we take common V, then 1 by R1 plus 1 by R2 plus 1 by R3. So this V and this V is cancelled. So from here we can write 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula for the parallel combination. R is the equivalent of R1, R2, R3 in parallel combination, and the value of R can be represented by this formula. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Suppose if you give an example, suppose one example, this is 2 ohm, 3 ohm and 6 ohm. These three resistances are connected in parallel. These three resistances are connected in parallel. Suppose this is R1, this is R2 and this is R3. So what is the equivalent? Equivalent, you know the formula. If R is the equivalent, suppose equivalent is R. Equivalent is R. Resultant of R1, R2, 3, R2 and R3 is R. So if you put the formula, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here 1 by R, that is equal to 1 by R1 means 2 ohm, 2, 1 by R2, R2 means 3 and 1 by R3, R3 means 6. So from here 1 by R, here the 2, 3 and 6, LCM will be what, 6. So there will be 3 plus 2 plus 1, we just simply we add this. So from here 3 plus 2 plus 1, 3 to 5 plus 1, 6. So 6 by 6 is equal to 1. So 1 by R is equal to 1. That means R is equal to also 1. So here we connect this 2, 3 and 6 ohm. These three resistance 2 ohm, 3 ohm and 6 ohm in parallel combination. The resultant becomes 1 ohm. The resultant becomes 1 ohm. So here we can say that in the parallel combination the resultant resistance is decreased. Here 2 ohm, 3 ohm and 6 ohm are connected in parallel. When the resultant becomes 1, that means less than all of the three resistances. So when we will use the parallel combination, if we need low resistance, suppose in any experiment you need 1 ohm resistance but 2, 3 and 6 ohm is supplied to you. So if you connect this 2, 3 and 6 ohm in parallel, then you will get 1 ohm. So you can prepare one low resistance by using this high resistance in parallel combination. So this is about the parallel combination, and this is the main formula of equivalent resistance. This is the main formula of equivalent resistance.